And we're live. Hello, everyone. How's it going? How's everyone's Friday? How can we get some music going? Background music. Hello, hello, Sumera. Let me know if the background music volume is good or if I should turn it up or down. Yeah, it's been a while. Whoops. Something just fell. All good. I'm doing pretty good. How about you? Looking forward to saving the world some more CPU cycles today. Hopefully you will manage. How's your Friday going? Hello, Prem. Haven't seen you in a while. Hope you're doing well. All right. Cool. So I guess we can already get started. So today's episode is going to be about Kubernetes metric server. So this kind of originated in, we had a couple of folks test the Polar Signals product, and they immediately noticed that metric server was way up there in terms of the processes that were using CPU time. Maybe I can actually already start sharing my screen because I set up a kind of vanilla Google Cloud GKE cluster, and it's pretty obvious when I share my screen. Also, let me know. Oops. Increase. Oops, okay. What happened here? Okay, looks like it doesn't like it when we have it. Okay, so basically, this is what the testers were seeing. We can see that across the entire cluster infrastructure, this particular container is using the most individual CPU time. So we felt like, maybe this is a good opportunity to dig into this on a live stream, so that we can kind of go through how do we go about troubleshooting something like this when we see it. In case you're not familiar, Kubernetes metric server is a component that you typically deploy in every Kubernetes cluster. and it provides you with functionality to be able to see CPU and memory using kubectl top. We'll have a look at those later as well. But basically, that's the functionality that this provides. And aside from kubectl top, this is also used by the various auto-scaling mechanisms in Kubernetes. So if you want to auto-scale, the amount of pods that you have to serve, let's say, some web server traffic, this is what you typically use as a source to determine, okay, my predefined CPU time that I allocated for this workload, it's starting to not be enough anymore. We need to spin up a new instance of this to kind of load balance it, for example. So that's typically what this component is used for. And for that, of course, it needs to collect the metrics. But actually, now that I've already started to drill down, what we can actually see is while it is the pod that contains the metrics server, it looks like that what we can see here, it doesn't look like it's actually the metrics server itself that is causing all of the CPU time. As we can see, the metrics server itself is actually very, very low on CPU usage. It's actually a sidecar that's sitting right next to the metrics server that is often used for vertically auto-scaling a single container or a single pod. And in Kubernetes, this is called the pod nanny. And so it looks like this is the component that we're going to need to be optimizing today, which is actually kind of cool because that means anyone that happens to use the pod nanny component to vertically autoscale some component is going to reap the benefits that we're going to be seeing today. In this case, the pod nanny, if I'm remembering this correctly, but hopefully we'll see as we go through the code base. If I remember correctly, the pod nanny actually discovers how many nodes there are in a cluster and then multiplies some predefined number of CPU and memory by the number of nodes that are in the cluster, and then uses that to auto-scale vertically the metric server in this case. So let's dive in. So it's already pretty obvious that it's the pod nanny binary here that is causing all of this CPU time. We can see it is pulling the API servers for something. It's updating some resources. Aha. Okay, so I think we're already starting to see what I was talking about. We're seeing that it's, I assume, trying to retrieve how many nodes there are in this Kubernetes cluster. And judging by these function names, count nodes through metrics, I'm guessing that it's, okay, we can see, okay, interesting. We can see that it actually decodes some Prometheus metrics to do this, and then text to family metrics. Okay, this is just, now we're just in the Prometheus exposition format parser. I'm not sure we're going to be able to find a lot to optimize in this exposition format parser, but I would say let's give it a go and let's dive into the code base of this add-on resize. Oh yeah, exactly. This pod nanny is also sometimes called add-on resizer. So let's figure out what repository this lives in. Actually, let me share my full screen and not just. not just a portion. All right. So what was it called? Add-on resizer Kubernetes. So it appears to live in the autoscaler repository that kind of lines up with what we're seeing here, k@s.io/autoscaler/add-on resizer. So yeah, okay, let's clone this repository. I actually already checked out the metric server repo, anticipating that we're going to be optimizing the metric server repo, but turns out that's not how it's going to go today. Interesting, actually, that I can share my full screen this time. That didn't work the last couple of times. Always let me know if my font size is big enough to be able to see and understand what I'm doing. Oops, now I don't understand why. Okay. So this is under Kubernetes/autoscaler. So I'm going to need to show here git git at Kubernetes autoscaler unlock our YubiKey. Now you see live that I have not actually done any of these optimizations beforehand. I've not even cloned the correct repository in anticipation. So we'll see if we can actually find anything that we can optimize today. And sometimes that's how it goes with performance work. We don't always find improvements. All right, so add-on resizer, and what did we see? This is a bit annoying, I have to say. I think I'm gonna actually not make the terminal full screen. Instead, do this. If I don't, yeah, now switching actually works easier. All right. Add-on resizer, then the nanny. Okay, yeah. Thanks for letting me know in chat. All right, now let's go back to the code that we're seeing here. So we're doing nanny/Kubernetes client. And what's happening in here? We want to look for the get node count from. Oh, interesting. Node count. Count nodes. Okay. Looks like it might have changed since last. Maybe someone has already optimized this and it just hasn't been rolled out. We've got the node lister. Let's go maybe further up the stack here. Count nodes, update resources. Where's this? This is in the nanny.lib. It's called update resources. So we count the nodes. Okay. And okay, that seems to call Kubernetes client and node count called node lister. All right, looks like someone might have already optimized this. Let's have a quick look into the repository. Okay. That was 4 years ago. Interesting. What version do we have deployed of this thing? 5052. Okay. Cluster autoscaler. We're not looking for cluster autoscaler. Add-on resizer. Okay, but no, that's cluster autoscaler. Let's have a look at our Kubernetes cluster actually. Let's first make sure we're actually looking at the right Kubernetes cluster. Yeah, this is right. We want to look at the kube system namespace. And we want to look at the metric server. Okay, it's add-on resizer 1814.gke3. Okay. Maybe it's a GKE specific thing. Add-on resizer 14. Okay, that seems pretty recent. And this does count through metrics. Okay. Was this removed? Metrics-based add-on resizer. Okay, that's much newer than the 4 years that we were looking at before. Yeah, I think Lily, you're right. This was merged into add-on resizer release 1.8. Okay. Add-on resizer release 1.8. Okay, looks like these are maintained on different branches. Okay, and this looks like it has some pretty recent commits. So let's have a look at this again. Okay, this still has count nodes through metrics. Okay, so it looks like we've at least found the code. Let's first, before we do anything else, let's then check out this branch. Add-on resizer 1.8. It's release 1.8. Okay, that looks better now. Kubernetes client. Oops. I already have this open, but now we've got, so it looks like our add-on resizer must be deployed with this use metric flag, I assume, maybe configured. Where's the set use metrics? New Kubernetes client. Okay, we set it through that, so let's understand where this new Kubernetes client is called. Looks like, okay, main pod menu, new Kubernetes client, use metrics. Okay, this already looks like flags to me. Flags, use metrics. Okay, whether to use API server metrics to detect cluster size instead of the default method of listing node objects from the Kubernetes API. Okay, interesting. I wonder why GKE actually does this. It could be reading nodes from the Kubernetes API may just be very, very expensive. So, I see. Okay. So what this is doing is it's instead of listing all node objects through the Kubernetes API, which can be, very, very large, and it returns a ton of information that's very unnecessary to be returned because all we want to know is the count. It scrapes the API server metrics and counts how many, did I understand this correctly? And it counts how many times that some etcd metric is present. Where did I see this? Yeah, here it is. So using etcd object count metric to exposed by kube API server. How come etcd object count? Let's quickly understand this metric in Kubernetes. Let me make this a little larger. Okay, this is also interesting. Looks like this metric is even deprecated. Number of options. Okay. Okay. It's a little different from what I thought. It's not counting the number of series from something. It's looking at how many node objects are there accounted for in etcd. Okay, this makes sense because there will be truly a single metric only, a single time series that will tell us this count. Okay, that's pretty clever actually of the Google people, I guess, to do. Maybe. Okay. Now that we hopefully kind of understand what's going on, let's dive into this. So we scrape the API server metrics. I wonder if we can get. Let's first understand. Let's first understand what this does. But it feels like if there's anything for us to optimize here today, we're gonna need the output of the metrics endpoint from the Kubernetes API server to do this. So we do get node count from decoder, and it passes the whole thing in there. Okay, that's interesting. So this we'll need to read some more of the code, but a theory that I have here right now is this is going to parse the whole metrics output that is returned. But we're only looking for a single metric name. that right? So we so it looks like we're truly iterating over the whole metrics output. And we're looking, okay, so there's two, so there's object count metric name, okay, API server storage metrics. I guess this is maybe the new, hey Nicholas, what's up? I guess this must be this new metric that the OpenShift documentation is, you know, if we had a subscription, would tell us. Okay, stable version. Ah, look who it is, Han. I used to work with Han a lot. Wasn't mentioned. Okay. Ah, looks like I was even still involved in this somehow. I don't even remember this. Okay. Okay, that makes sense now. So we have an old version of this metric and we have a new version of this metric. But my theory still stands. We're parsing this whole metrics output when actually we don't really need to. We actually only have to look for those metric lines that start with these metric names. Parsing the whole metric output seems very, very, very wasteful to do. Like we don't care about anything except for these two metrics. So okay, I feel like there's something for us to optimize here with that strategy. So let's get ourselves that example scrape output, and then we can write a benchmark and see if we can improve anything. So let's create a test data. There was some way to use kubectl to do a raw request. Kubectl raw request. Kubectl get raw. Okay. Kubectl get raw. Perfect. All right, that was much easier than I thought it was going to be. So let's just have a look here. Okay, so this is a 3 megabyte output. Okay, and of this 3 megabyte output, let's do a quick test. Okay, it's not the API server storage. Whoop. I need to read the code again to remember what the metric name was called. So we have API server storage objects or etcd object count. Test data. Oh, I'm really not good at typing. Ah, yeah, here we go. Okay, so, okay, and this has exactly, oh, this is actually quite interesting. That means that we'll be able to search for a very specific line in this output. That's very cool. And this is stable. So this So Kubernetes actually has a mechanism to define metrics as stable, and it looks like, and there are very, very strong guarantees around this when that happens. So we want to understand. So we can basically rely on this metric, is what I'm trying to say. So that should mean that we can, here it is. We can truly just search for this output. And obviously parsing this line, and we don't even need to parse anything, right? Like we can then do a string split. We don't need the Prometheus parser even. Okay, so I think I'm pretty convinced now that we're going to be able to write something much more optimized here than what we had before. So let's start by writing a benchmark. So extract. Now, I do have to wonder what this output looked like before. Maybe I can use folks in chat. If you have a Kubernetes cluster that's maybe a little older, and you have the etcd objects count metric. Where is this? Where is this done? Okay, here it is. And you still have this metric. Let me know if the labels look exactly the same. I'm quite curious about that. But it looks like we've also found where this change happened. So, okay, this just added a new one. Maybe etcd objects count is still exists as well. Is it etcd? Get that right. Okay, let's look at the Kubernetes repo today, github.com. Kubernetes. And this was in staging, source, KDSIO, staging, source, KDSIO, API server package, storage at CD3. And metrics, finally we're here. All right, so etcd request, API. Okay, looks like it did actually get removed eventually. But again, if anybody in chat has a Kubernetes cluster where you can find this old metric, that would be pretty helpful, I think. But we can maybe also close this. And where in this new GitHub UI can you look at the history of this file? Does anybody know? Download file, no. I'm interested in, here, history. Add metrics on, okay, no, we're not interested in that. Swap name for start name. Okay, maybe this one. Storage, okay, no. Date metrics bucket, clean up deprecated metrics and usages. Um, drop requests, no. These are dropped requests. Maybe this is not the patch that we're looking for. No. Okay. Not quite what we were searching for. Okay, let's look at it in this version. Is there still? It was etcd object counts. Okay, so it is truly removed. Okay, sorry for going down that rabbit hole. Just needed to make sure I'm sane here. Okay. No, what I wanted to see. Whoops. I can't reopen this. No. Why not? What I wanted to see was whether the labels were the same. Why can't I reopen this? I'm actually confused about that. Anyway, staging, kit.sao, API server, package, storage, CD3, metrics, history. See if in this. Here it actually got removed. I missed it before. So this had also the resource, exactly the same kind of format. Okay, that is very, very good. That means that we can, let's take a note of this. Notes. You can search exactly for these two strings. In our metrics output. So I think now we have everything together. We have an example metrics output. We have exactly the string that we're going to be searching, strings that we're going to be searching for. And now all we need to do is actually write a benchmark for this. So I think what we're going to want to, whoops, that was unintentional. We're going to want to maybe extract this. And we basically only want to write a benchmark for this particular function. This is not even bound. So we're going to do at node count from metrics reader. And we want to do it form error. And what we're going to do is today we're going to return this, and this is going to do return. Okay. We just pass in the reader. It's io.reader. Help. Read closer. Okay, we can live with that. Read closer. Here. And reader. Okay. What's your name? Okay. So yeah. Anything else here? Okay, so does the decoder close? Interesting. Do we defer closing? We also don't defer closing this. That actually also doesn't seem like a particularly good idea. So let's also, actually, let's for a moment ignore this, and we just want to improve the performance of this thing. We can worry about kind of correctness things another time. All right. Let's get the Kubernetes client test. Let's make sure that tests actually still pass. All right, tests pass. That's good. Are there any benchmarks? Okay, there are no benchmarks over here, so we're gonna start with a new one. Benchmark. Okay, Prem verified for us. I'm on 126 and can verify that API server storage objects is there and etcd object count is gone, and then a new metric has the same resource label. All right, yeah. Changing the label name is practically impossible now that it's a stable metric. So get node count from metrics reader. And it's testing.b. Now, making sure again. So we called it get node count from metrics reader. Okay, cool. So then what are we gonna do? We want to make sure that this scrape output is already in memory so that we don't account for reading the file every time in our benchmark. So, whoops. We want to read the content. And we're going to use, oh, that was pretty good. Let's actually rename that file. I like that. Not metrics, but metrics to metrics.txt. And does this thing expect error or count? I assume they just use regular testing package. Okay. Okay, so if error no, then we want to fatal. We want to reset our timer. Yeah, we want to run this several times, and then we want to create a new reader from the bytes every time. We are going to want to make sure that this doesn't get optimized away, so we're gonna node count U in64. We're gonna error already, so okay, so now we can do this and node count. What's wrong with this? Does not implement read closer. Okay, then actually let's skip that and just has the reader interface for now. All right, looks like we finally have our benchmark. So go test, run, we'll do our good old trick. What is it? I always have to. Okay, so what this means is we'll run all the regular tests that are empty string. So that's impossible, so we won't be running this. and we want to run our benchmark. That looks like this. All right, so actually, let's do something cool. What we can do in this case, actually, because we're processing number of bytes, is we can do b.report metric. No, not report. What is it? I always forget this. Set bytes. That's the number of bytes processed in a single operation. Okay, cool. Then we can just do this once. Set bytes. Oh, our benchmark again, because what we then see is how many. So we can do 46 megabytes per second, which is not bad, right? But scanning text for a predefined kind of string is certainly much, much faster than 46 megabytes per second. So let's commit this. So this, we'll skip our notes, but we'll add our test data as well. Now, so I commit. What is our nanny at benchmark for parsing for getting node count from metrics. All right. Now we have our baseline, and we actually need to. How do we do this again? txt. Right. And we actually want to write this multiple times. So let's run this benchmark 10 times. So we have some statistical significance. That's why we do this. As we can see, we only get 16 to 18 samples every time we run this. So it's a good idea to run this multiple times. And let's just make sure, okay, now we truly have our baseline. So now we can play around and see if we can optimize this. So get node count from metrics reader. And this did a whole bunch of work. Got preferred metric. What does this do down here? At least one metric present, but all present metric. Okay, this is in case we find potentially both. And if we found the object count, interesting. They prefer. Do I understand this correctly? They prefer. They prefer the new metric, and then fall back to the old one. Okay, makes sense. Okay, we can get some logic for that. But basically, we're just gonna completely replace this, and what we're gonna do is, it's like a scanner or something. It's going scanner. Also text scanner. I'm looking for this one, Buff.io scanner. This is the one that we want. And it has a split function. Lines is what we're looking for. Okay, so this is pretty straightforward. We can just copy this. We're just not scanning from standard in, we're scanning from our reader. And we want to, let's see, print line, yeah, no, we don't care about any of this. Let's initialize our result and go worse than zero metric, zero node count, so U in64.0. We return that and a nil error if we don't run into any errors. And now let's define some constants with our nodes. The object I don't know. I don't really like it, but don't have a better idea yet. Let's just do this and then escape these. And then API server storage object. Okay. This. All right. Now we've got our two constants that we're going to be scanning for. So now all we want to do is we get our line from our scanner. And specifically, we do not want to use the text function because that allocates, as we've learned in previous episodes. We just want the bytes. And then we can use the bytes.has prefix. And we can do this right away. And we don't need to do this casting. Is that a cast? No, it's probably boxing or something. Not actually 100% sure that the Go compiler is going to allow us to do this. It might say that this is a mutable thing. Yeah, it's not a constant. Okay. That's exactly what I was afraid of. Okay, then maybe we do need to do this, and we'll see if maybe it's negligible. It probably is. All right, so has prefix. This is let's first check for our preferred one. API server storage objects. Okay. And if we find this, what we want to do is, yeah, it actually does this correctly. We want to parse the integer by splitting the line because there's no, the only thing we have is the space between the metric identifier and the number. And then we return. Yeah, actually this makes sense, except we probably want to make sure that we actually get exactly two from this. There's actually a Golang bytes. I want to see if there's a split here. Yeah, cool. That sounds good. I like that better. Bytes split and we want to split at least with most n. Okay, so yeah, we definitely don't want to cause an allocation here. And we want to produce at most 2. we have parts. And the parts is unequal to unexpected format of metric. Yeah. String. Hello, hello, Anu. Hopefully I pronounced your name correctly. Welcome. So now we know there are two parts, and we can choose part 1 to parse. As we've seen in a previous episode, though, this particular parse function is not very optimal. So, but it only occurs pretty rarely in this case. So I'm not actually sure we need anything else. What did it not like about R here? Too many. No. Split n is what we want. This causes an allocation. I don't like it, but we'll accept it. Simply closed my editor there. Okay, so this is something that we can actually abstract away. So parse metric. We have line is byte slice, and we return a UN64 error. Because we're going to want to do exactly the same thing for both of our findings. So now we return parse metric value. Yep. Why does it do that? Interesting. So we actually don't need to do any string splitting. This needs to find the string. We already know that it has this prefix. And what we can do is we add this empty space here, then we can just strip it away in that way. Yeah, I like that. So at this point, we already know. Okay. We already know that it has this prefix, so we're just going to strip all of that away. We're just going to cut the string at exactly the length of this prefix. So we know it has the prefix, therefore it's definitely safe to cut it at that point. So maybe we don't need to abstract this away then. Yeah. So in this case, we take line and we cut it at length of, we start at length of, so we're cutting this line there, and what is it saying? Missing comma before new line argument. I think this should be it. Yeah. Okay, and we actually don't need to do this. And this actually is an error. No metrics on. I think there was already a predefined error. We'll fix it later on. For now, I just want to make sure that just want to focus on the optimization. Okay, and now we just return our result. Right, now we copy this and do exactly the same thing here, except we want to work off of this instead. Okay. I think we're done. Let's give it another try. Okay, I'm undefined res 201. Okay. That code that we forgot to delete. Okay. 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 I think we've got something. So if you remember correctly, we had previously about 49 megabytes per second, if I remember correctly. We're gonna want to make sure that this is actually still correct, right? That we actually get the results that we want. So we want to make sure that the remaining tests still pass. But clearly, this is a major improvement. 99.44% improvement. Don't see that very often. Okay, let's see. And our tests still pass. Actually, I think even these tests run faster now. I want to go back. We did run them earlier. I know this is the benchmark. Okay, it's a little faster. It's not significant. That's awesome. Okay. Let's compare the two functions. Make sure that we will do the same thing. We're also, since we're already on it, let's make sure that we close this reader. We're done with everything before we forget. All right, so let's take our function and a little bit, whoops, a little bit larger, smaller, so that we can fit both of the functions side by side. Okay, perfect. And our previous function was where was it? Get node count from decoder. At least one metric present, but all present metrics have errors. Okay. I'm not sure that's useful. Okay, but there's no metric set. So let's return the same thing here. I think we're done. I didn't expect us to be this quick. I mean, this should basically remove, if we go back to our metrics from earlier, we can see that, 70% or so, 68%. It might also improve garbage collection, right? Can say that for sure. Actually, maybe today we can even deploy this. We might give it a shot if we can build it. But theoretically, all these 70% should pretty much disappear with 99.4% improvement. There's probably then going to be all these other things over here that are going to dominate this workload. But I think at this point, this workload is probably no longer interesting to look at performance-wise. Cool. I mean, that should mean that it should definitely drop down to all of these insignificant things in this Kubernetes cluster. Okay, let's give that a try. First, let's clean up and commit. So we want to move this function. It's no longer used. Also unused now. Not through API. Okay. Test. Oh, extract metric value or node. Okay. I guess there were some tests for this stuff. 193. I think we can we should just remove this. All of this stuff is just completely unused now. Test get node from decoder. This does a couple of that should probably be written anyway to be based on. Yeah, exactly. It's always an unsigned integer, so this should be okay. Yeah, but definitely a good point. So there were a couple of notes in chat. Shodan mentioned if this had been JSON, we may not be. It may not be okay to do this, but in this case, we know it's counts, and as Prem mentioned also in chat, in the Prometheus exposition format, because these are counts, it will always work to parse these as an unsigned integer. But that's very specific to this situation, right? Because we know we have counts. So this is something that we see time and time again when we work with performance of software. This is a very specific case, and that's why all of this happens to work here. But it's not necessarily a generic thing that we can always do everywhere. For the moment, I think I'm going to remove these, and I'm going to see what the reviewers say once this is getting reviewed. Okay, let's see. Okay. Now, let's commit this. Let's take our improvement, our very, very nice improvement, copy this, and commit it. Improve parsing of metrics output. Because we are searching for a very specific set of strings in the metrics output, it is wasteful to parse the Prometheus exposition format. Instead, we can just perform a text search on the output, which is several magnitudes faster. Here is the benchmarking output for and after. As we can see, this improvement. I guess we already don't need to evaluate it. All right. Now let's see if we can build this container. That'd be pretty cool, actually. Let's see. We see a Docker file. I see a make file. This could be promising. Actually, let me fire up Docker. Push multi-arch. What's going on? No builder, image builder. What is that? I am building. Maybe let's have a quick look at the repository to see if it has some documentation as to how to build this thing. It's in here. Okay, base image, botany. Okay, pretty sparingly documented here. Maybe in the top. Have some more contact info, getting the code. Doesn't look like we have any like CI boilerplate. Doesn't look like we have any CI configuration here either. That does not make me very hopeful, but let's try around a little bit and see if we can figure it out. Build X setup. Image builder. Container arch. Build the okay. This at least builds the Go container in there. I don't really understand what this does. Let's just in giggles. We can still build it. No. Extra characters at the end of the command. What is going on? Oh god, is this like an BSD set thing? Let's see. Here, I guess it creates a new temp here, or what? Happening? Yeah, it makes it create a new temp here. Yeah, this is the problem. Okay, maybe we can fix this by doing edit the files in place. Why is this extra characters? It should edit it in place, no? Always fun. These things. If anybody in chat sees or knows how to do this, I'm almost certain it's some sort of GNU set versus OSX set thing. Extra characters at the end of. Let's Google it. If you want to disruptively overwrite the original file, use something like this. Note the space. Okay. We want to do that. Okay. Let's try what we've just found on. Okay, so it looks like this would do the trick as well. Okay. All right, we are building. Now I'm gonna need to push this somewhere. So I'll need to find a location for that. To do that, let me actually log into. Actually, I might do this on my other screen over here. Haven't done this in a while. Let's love this. We all see something happening. All right, let's log into my Quay account. All right, cool. That worked pretty well. Oh, wow, this is still downloading the Go container. That's very slow. What is it doing now? Downloaded newer image for Golang 124. Okay. All right, it's building. Cool. And we're building it for AMD 64. Nice. You can see, okay, it's building it. with 1819. Wow, this is very slow. What is this doing? Hello, Matthias. Welcome to the fun. In case you've only joined now, we managed to get a 99.4% improvement on the add-on resizer. So we were actually pretty quick with that today. And we're now going to try to deploy our improvement to see, whether it actually translates into that improvement that we hope to get. And we saw about what we optimized should be about 70% of the CPU time, but it may actually additionally relieve the garbage collector a little bit. So hopefully we will have improved more than 70%, because that's the code path that we optimized by 99.4%. So like almost 100% is gone, right? All right, so let's tag this thing. And I'll push it to my personal one. Hopefully, actually, GK even allows us to override this. We'll see. Maybe we won't have any luck today with this, but we shall try. So we retag this thing. Now we want to push it. Okay, nice. Looks like I am actually authenticated with Quay. That's awesome. So, and we called this thing what? Add-on resizer MD64. This is actually a really cool feature of the Quay registry. You can just push anything, even if it doesn't exist yet. It will automatically create the repository for you as a private repository, and then you can just go in and make it public after you've pushed for the first time. I think it's pretty neat. I use this a lot, especially when I do testing like this. All right, cool. Now let's actually deploy this thing. That would be very exciting to see. We don't actually want to modify the metric server itself, but we do want to change this. All right, so now this is not the one that we want. We want quay.io/add-on resizer -64 1819. Okay, and we're deploying it. Something's not right with my keyboard today. Whoops. How come this is not deploying? This may be exactly what I anticipated, that maybe GKE does not allow us to mess with this. Let's see. Yeah, I'm pretty sure allowing us. That would be a shame, but we can verify this by doing this, and then editing this one more time. I'm pretty sure what's happening is that they constantly overwrite this to make sure that you don't make a mistake. Maybe someone knows that you can, Oh, Prem, did you say that oh, I made a typo. Okay, interesting. Let's double check that then. Play.io/branch/. This time I'm gonna copy it. See all of my repositories. There we go. Make sure we don't do this. Also copy the tag, just to be sure. I think they already overwrote it back. Of this. Yeah, I mean, I think this is unsurprising. GKE probably doesn't want us to mess with this thing. Yeah, it's GKE managed components. Maybe we can atom manager reconcile. Maybe we can turn this off. Good thing this is a demo cluster and not a prod cluster, so I'm comfortable with messing with this thing. Okay. Third time's a charm, I guess. Again, why do I keep closing this tab? All right, I'm starting to get the feeling that we're not going to be able to modify this thing. Yeah, I have to reset it again. Last chance. Let's Google if we can find something about this GKE deploy custom metrics. Reconciled metrics server. GKE disable reconcile. If we've got anyone who knows how to disable this, that'd be helpful, but maybe we cannot. Components layer add-on. We could definitely remove this. Oh, Yeah, unfortunately, it looks like we're not going to be able to deploy this today, but just to show one more time, we managed to optimize the pod nanny add-on resizer by 99.44% in this particular code path. And just recapping from the profiling data that we started with, we optimized away, something in the realm of 70% of CPU time here. Maybe, like I said, that would actually also take some pressure off of the garbage collector. So that should mean that we improve the CPU usage of the add-on resizer by at least 70%, potentially even more. So with that, hopefully you all enjoyed this episode of Let's Profile. As always, if you have any suggestions of what we should be profiling next and optimizing next, let us know. It does typically help if we run this piece of software in some sort of cluster, so that we have some profiling data to work off of course. That's kind of the reason why we're doing all of this, right? Like showing that we have to have profiling data in order to make informed decisions about optimizing code paths. But if you have anything that's pretty easy to deploy, I'm more than happy to do that as well. Of course, it helps if we have realistic kinds of traffic or load on those deployments. But yeah, I think we can call this yet another successful Let's Profile episode. I think this was an interesting one. I'm not sure we've actually had a case where we truly could just prevent doing something altogether. So this shows it's not always about you need to know where allocations happen or whatever. In this case, it was already good enough to change the whole strategy. And as a matter of fact, most of the time, that's how performance engineering ends up happening. The kind of micro optimizations of saving an allocation here and there, they tend to happen, and they tend to be most helpful in the later stages when you've figured out, what is the right strategy of executing something, solving a problem, and then because the strategy itself tends to be the thing that has the biggest impact. All right, cool. Thanks, everyone. We had a pretty lively chat today. That was really awesome. So I hope to see you all next time. And again, if you have any topic suggestions, let us know on Twitter. Follow us on Twitter, follow us on YouTube, like and subscribe this video, or if you're live, the live recording, and hopefully see you next week. Thanks everyone for joining. Bye-bye.